Hello everybody, and welcome to part 10 of my FTC Programming tutorial videos. We are now in double digits. In this video, we're going to talk about the IMU, or Internal Measurement Unit, that comes pre-installed on every Rev Expansion Hub and Rev Control Hub. The IMU is primarily used to determine pitch, roll, and yaw of your robot, specifically in the context of things like field-centric drive and autonomous. We'll talk about some of those concepts in future videos. This video is just going to be about getting the IMU set up and how to retrieve some of this information. So let's get started. Now, I do apologize. I'm going to be a little bit slow kind of typing this out because we're starting to get into territories of I'm going to have to look at references in order to make sure that I get all this information correctly, because I don't have quite all of it in my head at all times. All right, so the first thing we need to do is we need to import everything we need. So there's going to be 3 import statements for the IMU, and you'll kind of see what each of them are for in a minute. I'm just going to go in alphabetical order, so it's okay if things don't really make sense. So the first thing we need is we need Rev Hub orientation on robot. We then, of course, need the IMU itself, and then we also need angle units. Now, each of these things, the IMU is the IMU itself. Rev Hub orientation on robot is going to let us orient the hub, because obviously the orientation of the hub, whether it be upside down, vertical, flat, which direction it's facing, is going to determine what constitutes a pitch, roll, and yaw. And then the angle unit is going to determine what kind of units we get out. So are we going to get out degrees, or are we going to get out radians from the IMU itself? So in initializing the IMU, we have to create a new IMU object, which I'm just going to always call the IMU. And we are going to get it from, you probably could have guessed this maybe, from the hardware map. And if you remember hardware map, it's just hardwaremap.get, imu.class, and then this is almost always going to be just plain text IMU. This is going to be like kind of pre-set up when you create a new config. It shouldn't ever change unless you specifically go and change it. If you have problems retrieving this, so like for example, if you try and launch a teleop mode that has this in it and it says it can't find IMU, then you would kind of go into the steps in troubleshooting your configuration. This should be set up by default, and you shouldn't have to touch anything. If you do, something has gone wrong. I'm just going to leave it as it is, and if I need to, I can kind of walk through the steps in configuring something like that, if that's helpful. All right, so the next thing we need to do is we need to create our initialization parameters for our IMU. So IMU.parameters, I'm just going to call this variable parameters. And we need to, this is going to get a little weird, so we need to create a new IMU.parameters object, and we're going to pass in a new Rev Hub orientation on robot. Now, this needs 2 things. It needs the direction that the logo is facing, and it needs the direction that the USB is facing. There is a page on, can't quite remember if it's FTC or Rev, that kind of illustrates how you should set this up, but I will provide that in the description, and it provides examples for how you should pass in these things. But if you can kind of just think about it. So if we have a control hub, and let's say the USB is facing you and the logo is just facing straight up, if this direction is forwards on our robot, then we want to pass in the information that the logo is facing up and the USB is facing forwards. If this direction is the back of our robot, then we want to pass in the information that our USB is facing to the back. It's robot-centric, so it's not centric to anything with the ground. So for example, if your control hub or expansion hub is completely upside down, but your robot starts on the field upside down, then you wouldn't tell your Java code that the hub is upside down. You would tell your Java code that the hub is right side up, and then it would know that your robot's actually starting upside down. Things like that. You can kind of play around with it and see what makes most sense for you, but I'll provide a page in the description of this video to kind of illustrate some of those points. So in the context of this video, I am just going to say facing direction. I'm just going to say that the logo is facing up, and I'm going to say that the USB is facing forward. Now, obviously, this is going to vary depending on how you have your robot configured, but that's just what I'm going to do for the context of this video. And then you'll notice that this parameter variable is actually completely disconnected from our IMU variable. They haven't touched each other at all. So now we need to pass in the IMU initialize with our parameters. So now we have our IMU completely set up. This is what you would need to do before you actually start running your while op mode loop. You can run it after your wait for start, but beware that the IMU is probably one of the things that takes the longest to initialize. This was actually recently approved in the 2023 version. We used to use the legacy version of this, which was the botch IMU. That took anywhere from 100 to 900 milliseconds to initialize. This version of the IMU takes anywhere from 50 to 100, so it's improved significantly over the last few iterations of the FTC robot controller. So now that we have all of this, I'll briefly show how to get some information out of the IMU. So I'm just going to store this in a double, and let's get the yaw. So the yaw is going to be, I believe it's going to be the rotation this way of our IMU. So if we have our control hub and the USB is just facing forward and the logo is facing straight up, the yaw is going to be the rotation this way of our expansion hub. And that is generally going to be the thing that we're going to use in order to determine our heading. So to get the yaw, we need to do imu.getRobot yaw pitch roll angles. Now this is going to return to us some funky thing of, it's some type that we don't want to worry about that contains all three of these pieces of information, pitch, yaw, and roll. We don't want that, we just want get yaw. And now we have to also pass in the type of units that we want. So I am always going to do radians, because when we start using some trigonometry to actually determine, you know, how things are rotated, we want radians always, because we're going to be using sine, cosine, and tangent functions. But you can, of course, use degrees if you just want to print this to telemetry, a concept that we'll cover in a future video. And it's kind of up to you. But if you want to use this for something mathematical, so for example, we're going to talk about field-centric drive, we're going to need this variable to be in radians. All right, so that's all I got for you in this video. The IMU is something that is very, very important. We're going to use it a lot in some coming videos. We're going to use it for field-centric drive, and we're also going to use it quite a bit in developing our own autonomous routines. So hopefully this video was helpful. If you have any questions, please let me know.